Dear students, welcome to the video The Geometric Distribution. A discrete random variable x is said to have a geometric distribution and is defined by its parameter p if it meets the following criteria. First one, the repeated trials are independent. Second one, the number of trials can be infinite in number. Third one, there are just two possible outcomes for each trial. Success denoted by P or failure denoted by Q. Fourth one, the probability of success in each trial, which is denoted by P, is constant. Now consider the situation in which you are attempting to roll an ordinary fairy dice in order to obtain your first 6. If the first trial is 6, the probability will be 1 over 6. For the second one, it means that the first trial was not 6. So it will be 5 over 6, which is not 6, failure times 1 over 6. In order to obtain your first 6 in the third trial, it means that the first 2 trials are failures. This is a type of an example for the geometric distribution. It means that in order to obtain your first success in the rth trial, it means that r minus 1 trials are failure. Failure will be 1 minus p, which is denoted by q. And your first success is obtained in the rth trial. So r minus 1 are failures. Then the last one will be a success. So a random variable x that has a geometric distribution is denoted by x. Geometric p, the parameter is p, which is probability of success, and the probability that the first success occurs on the rth trial is, so probability of x is equal to r, means that your first success is obtained in the rth trial. It will be 1 minus p, which is actually q, to the power r minus 1, because the first r minus 1 trials are failure. Then the last one will be success. For r is equal to 1, it means that your success can be obtained the first trial, second trial, third trial, and up to infinity. Example 1. Repeated independent trials are carried out in which the probability of success in each trial is 0.66. Correct to 3 significant figures. Find the probability that the first success occurs and part A on the third trial, part B on or before the second trial, part C after the third trial. Now, the first part, it says on the third trial. It means that your success is going to be obtained in the third trial. So it means that the first 2 trials are failures. The probability of failure will be 1 minus 0.66 to the power of 2. You have 2 failures, and the third time will be success. The probability of success is 0.66, which will be equal to 0.0763. Part B, it says on or before the second trial. It means that x less or equal to 2. Less or equal to 2 means that your success may be obtained in the first trial or may in the second trial. So probability of success in the first trial, so it will be 0.66. In the second trial, it means that the first trial is failure. Then the second trial will be success, 0.66, which equals to 0.884. And for the third part, it says after the third trial, x greater than 3. So we know that the number of trials may tend to infinity, so you cannot calculate all these after 3. That's why we calculate the other part and subtract from 1. You can write x less or equal to 3 instead, subtracting from 1. So 1 minus probability of x is equal to 1 or 2 or 3. which is equal to 1 minus. Probability of success in the first trial will be 0.66. In the second trial, it means that the first is failure, then the second one is success. In the third trial, it means that you have 2 failures, then 1 success. Then the answer will be overall 0.0393. There are some key points concerning the geometric distribution that I would like you to pay attention to. Probability of x less or equal to r, it means that probability of success on one of the first r trials is equivalent to say that it is 1 minus probability of failure on the first r trials. So probability of x less or equal to r will be equal to 1 minus q to the power of r. It's a really important point that can be used in solving questions. The next point, probability of x greater than r, means that probability of first success after the r trial is probability of failure on the first r trials. So it means that probability of x greater than r can be obtained by q to the power of r. Now let's see some examples concerning these 2 points. Example 2. In a particular country, 18% of adults wear contact lenses. Adults are randomly selected and interviewed one at a time. Find the probability that the first adult who wears contact lenses is part A, one of the first 15 interviewed, part B, not one of the first 9 interviewed. For the first part A, you are supposed to find the probability of that success is obtained in the first 15. One of the first 15 interviewed, so x less or equal to 15. Now if you use the point that you learned in the last page, you can write it is equal to 1 minus q to the power of 15. The probability of success is 0.18, so probability of failure is 82. Now is equal to 1 minus 0.82 to the power of 15, which is equal to 0.949. Part B, it says not one of the first 9 interviewed, so probability of x more than 9, so can be written as q to the power of 9, 0.82 to the power of 9, giving you an answer of 0.168. Example 3. A coin is biased such that the probability of obtaining heads with each toss is equal to 5 over 11. The coin is tossed until the first head is obtained. Find the probability that the coin is tossed. Part A, at least 6 times. So probability of x greater than or equal to 6. We cannot use that point that we used in the previous example because you have equal sign here, so we can change it. X at least 6 means x greater or equal to 6, so we can convert it to x because it is a discrete random variable and they take whole numbers. We can write it x greater than 5, so can be written q to the power of 5 then. So 5 over 11 is success, so failure will be 6 over 11 to the power of 5, which is 0.0483. Part B, fewer than 8 times x less or equal to 8. So here, it says fewer than x less than 8. Now again, here we need to have equal sign. We can less than 8. The first number before 8 will be 7. So x less or equal to, as we have discrete random variable and they take integer values, you can do so. X less or equal to 7. So 1 minus q to the power of 7. 1 minus q is 6 over 11. Then 0.986.